winding down and winding up, looking for a hole in the blogosphere or whatever it is out there to instigate, participate, and masticate on what in fact is the reality of learning right here. And so I'm looking for a hole, and one of the holes I see for now is people putting together mathematics and SketchUp visualization in some approachable manner. And so playing around with the idea that in 5th grade, once you understand the concept of the circle, the square root, and the ability to do something called the lattice method based on Napier's bones in mathematics, some kind of cross odd multiplication using number place, you can do animation. And I would not be could not be disproved if you went out and looked at what's happening out in the kid world and modeling and playing around with robots as well. So I give to you now the Ruby code editor and SketchUp here, and I'm going to bring up one other window, and that window is in fact the Ruby console, and we'll see if we can get that to fit down here in the bottom right. Right now, putting these videos at 1280 by 720, and maybe later get with the program and go a little higher if this will get smaller. So this is going to probably tend to wash out a little bit, but we'll put this one here. And showing you, in effect, how simple and straightforward it is to not necessarily go with the easy, but go with the transferable when it comes to comes to doing animation and transformation matrices. So one of the things you're going to see is entities. There's some basic starting definitions that you need to do in any Ruby script in SketchUp, and that is to define your model, define your entities, define your selection, define your definitions, and define your view. So I'm going to go selection equals model dot selection, and then of course definitions, which isn't always necessary, but these in fact are your blocks or your repeating shapes, equals model dot definitions, and then view equals model dot active underscore view. And so you start to see this concept of in Ruby, which is essentially an object-oriented program, the dot more or less forces the command into the variable. So here you see that you take SketchUp and you take something called the active model and you call it model. Within that model you take the entities and you call those entities. You call the selection, you call it the definition, and you come with that. And all I'm going to now do is put in a script that's going to manipulate the one object I'm going to put on the screen here in a little bit. So go to that, and now you can basically start to use transformation matrices. And there's a great set of them in there that you're going to want to do, but you do want to start to understand the basics of how transformation matrices work, them being a 4x4 matrix, which is a typical 3x3 rotation scale matrix. Stacked onto its right side is a vector that's a transformation vector, and across the bottom is 3 zeros and a 1. That 1, of course, can change the scale, and actually in an inverse way. So if you want to scale something up, you make that 1.5. So that said, the way you just go ahead and make a regular old identity matrix is to do this. You might call it trans1 t1 equals geom, that, and then a capital transformation dot new, and that's going to go ahead and just make a blank matrix that basically is a 16-place array going from place 0 to place 15. And then you can take and convert that A1 to an array by saying T1.toArray. That's actually going to make it something you can manipulate. And for now, I'm just going to let you know one of the great things about the list or the array structure in Ruby is you can count from the beginning, 0, 1, 2, 3, which is relatively common in higher order mathematics or programming, or go backwards from -1. So whereas you number things from 0 to 15, you number them backwards from -1 to -16. So in this case, I'm going to count back, and I'm going to say now the A -4 place is in fact equal to 10. I'll make it 10.0. And now, in fact, we have changed that matrix so that now we can say T1 equals geom transformation dot new, and then we give it an A right next to it. Realistically, you probably want to put that inside of an A there. Hopefully that would be something to do, and you also do not want to put spaces there. So that's going to go ahead and force that back in the matrix. And now if you use that matrix to just transform entities, which I'll say now, entities dot transform underscore entities, tell it the transformation, T1, and then the entities you're going to do, which is in this case just the first entity. And that should in fact then move the one entity, or the first entity in the design or the plane, by 10 units in the X. So that's all you've got to do. What you can do after that is start to loop and whatever else. So you notice we'll do it once, and then we'll change that from a -4 to a -3 and see how it moves in the Y, and then a -2, see how it moves in the Z. And even in the end, I think we'll try to go ahead and change it to the -1 and see what happens. So let's go ahead and put one entity in here. I'm going ahead and drafting something and then immediately going across it, right-clicking on top and making it a group. So now there's only one entity at the base level, if you would, at the model level of this model. The Ruby console is up here because that's where you can see your errors. So we're going to see if I made any mistakes. This never works the first time, and it didn't work there either. So if you notice here, it was A1, not A, that I called the array, and I'm going to do that here as well, A1. So now we're going to try it again and see what happens, and you see the thing moved. Run it again, it moved again, moved again. I can go now here up to that and say -3. In other words, the Y place, and you won't necessarily, I guess you will, 1, 2, 3, and then I can go ahead and do the -2 place, and you see now it's moving up in Z. Now what we're going to show you is, let's go and see if in fact my recollection or intuition was true, that the -1 place or the 15th place in the matrix is a scale that works in the reverse. And what you'll notice here is this is going to scale about the 0, 0, not about the 0, 0 of the actual object. So I'm going to say -1 here and run. You're going to see that's going to get 10 smaller. And if I make it 0.1, it gets 10 larger. Realizing it's got to be 0.1, it's going to get 10 larger there. So you get the sense that really manipulating matrices, even though you could go about doing it with some of the special commands, with is just, transform and give it a vector, it is reasonable to play around, especially if you've worked on the side here and done some of the kind of discussion of what a transformation matrix looks like, and develop your own set of little tools, just so that you're not just going straight to the program, you're making something that's going to be transferable towards deeper or higher thought, or maybe transferable to doing something a little bit more basic if you're going to actually have to be tested on those old 20th century skills when you're trying to move ahead to the 21st century. So let's go ahead and finish this out a little bit here. I'm going to pull this out and take a look at what actually was the unusual code. This first 1, 2, 3, 4, 5 pieces of text are standard definitions in any SketchUp Ruby script. The next one is to basically making an identity matrix, which is a 4x4 matrix with ones going along the diagonal, shifting that transformation, quote unquote, data structure into a pure array, changing one value of the array, shifting that array back to a transformation matrix, and then transforming entities. So what in fact does this look like if you are doing it in just longhand? Let's take a look and see if we can bring up smooth draw, because Sal uses smooth draw. And we're all realizing sooner or later, it won't be long, that we're all going to be kinetics. Because in this world where, in fact, there's good, bad, and ugly, but there's also incompetence, along with the passion, we got to be aware that the math of doing this, 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1, and multiplying it by any other set of x 1 y 1 z 1 1 x 2 y 2 z 2 2 dot 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 x the nth n, the yth n, the nth y, and the nth z, which is also ones, of multiplying these out, maybe used to be rocket science as we did this mathematics, but it is not very tough to do these transformations. And so what we did here, if you remember, we can begin, I'll go ahead and change the color, in an array matrix A, see if I can change the color, which I don't seem to have it. There's A. A went from spots 0 to 15, with this being spot 0 and this being spot 15. A could also be defined by -1 to -16 in terms of spots. And so this being -1 and this being -16. This, of course, is the translation. And so as I change the x there, that would be -4 position. The y would be -3, and the z would be -2, and the scale overall would be -1. Going forward here, these ones are probably easier figured out as position 0, 1, 2, 3, and then there's probably some relative way to train your brain that you could start flipping these things out. Realizing that if you are going to change something and rotate it about the z, you lock those up and you change which would be, in this case, A0, A1, A4, and A5. Those numbers change in that typical cosine minus sine, sine, cosine, could then be used to do your rotations. So 12 minutes there, some theory, some knowledge, and some pushing you out to Wikipedia, some pushing you out to Martin Reinhardt, I think it's called Edges to Rubies, in the SketchUp community, and even sticking you back into your old AutoCAD books or all mathematics books or any kind of thing with dealing spatial information. This idea of transformation matrices has been around a while. It's just that now kids are starting to do it and capable of doing it at about 4th grade. Thanks for listening. Hope you enjoyed it, and I hope you move forward and get out to see things like Khan Academy and BetterExplain.com and go from there and share.